This will be a quick video looking at the idea of independence and how we determine if things are independent. So first off, what we want to take a look at is what exactly is independence. And independence means one event does not influence the outcome of another event. So here's a quick example. Suppose a job requires you to fly from Atlanta to Houston every Monday. 85% of flights are on time. So with the chance that a flight will be on time 2 weeks in a row, if we take that as our event, does being on time this week have any impact on being on time next week? And the answer there would be no, they don't. So this looks like we have a situation of two events that are independent. Now again, if it was one flight right after the other, like two consecutive flights, that could have an impact on each other. But the fact that these are a week apart means they are independent. So let's take a look at another example. A survey finds 56% of college campus live on campus, 62% have a meal plan, and 42% do both. So let's take a look at the event that we randomly select a person that has a meal plan and lives on campus. So here, does living on campus have any impact on if you have a meal plan? And chances are, yeah, probably typically if you live on campus, you probably also have a meal plan. So this would be an example of two things that are not independent. Now, just as a chance to review very quickly, the fact that we have a 42% do both, this would tell us that these things are not disjoint or not mutually exclusive. But that, again, that's not the exact same thing as independence. And I'm going to point that out here in just a minute. So two events are independent, however. Obviously, we kind of see some examples here, but in terms of what we're going to do in this course, what you guys are going to be asked to do is you're actually going to do a little bit of work to find it. The things are independent if one of the two situations occurs. We have the conditional probability of B given A equals just the probability of B. So if you think about that for just a minute, the probability of B given A occurs is the same as the probability of B alone. So if you think about that just for a minute, B given that A occurs over here is the same thing as just B all by itself. In other words, A has no effect on B. And what we saw in the previous slide, if one doesn't have any effect on the other, that's where you get independence. The same way, just if we switch the events here, the probability of A given B occurs is the same thing as A. So to check for independence, notice that the first thing here is the same as the one that's all by itself. Now, a big note here. Independence is not the same thing as mutually exclusive. Mutually exclusive, you just look for an overlap, right? Independence, you're actually going to have to do some work, and we'll do a quick example, or a couple quick examples in just a second. So independence is not the same as mutually exclusive. So for example, we've seen this before. 56% of all Americans have retirement plans, 68% have health insurance, 49% have both. So I'm going to take a quick second and fill this in. So there's the one. 56% have retirement, which means that 44% don't. 68% have health benefits, so 32% don't. 49% have both. So now I'm going to take a minute, fill this in the rest of the way. And we can see, if I was asked, are these things mutually exclusive? The answer is no, because somebody has both. However, in just a minute, are these things independent? We're going to have to do a little bit of work for that. So first, what's the probability someone has a health plan if they have a retirement plan? Here's a conditional probability of health given that they have a retirement plan. So for us, remember, I would highly, highly encourage you to write this out. That would be health and retirement over the probability of retirement. So health and retirement would be 0.49, right? That's probability of both. And just retirement would be 0.56. And that number is 0.875. So there's a look at our conditional. The next question says, are these two things independent? Well, in other words, since we've already done a conditional, really we're trying to check, does the probability of health, given that they have a retirement plan, does that equal the probability of just the health plan by itself? Well, here's the thing. We already have health given retirement. Health given retirement was 0.875. And the probability of a health plan, if you look right there, is 0.68. Does not equal 0.68. So these two things are not independent. So I would encourage you, a lot of times you're going to see problems where they're going to ask you to do some type of conditional like they did in this first part. And we'll just use that answer, 0.875, That's the probability of health given retirement. So we'll just put it here into the equation. That does not equal the probability of just a health plan of 0.68. So these two things are not independent. So here's an example. They're not mutually exclusive because of the both, and they're not independent because of this work right here. You have to show that work. One more example. When playing cards, are the events Jack and Heart independent? Now again, mutually exclusive? No, because of this guy right here. The Jack of Hearts tells us there's an overlap. There's a situation where you can have both a Jack and a Heart. These are not mutually exclusive, but we have to answer the question, are they independent? So let's take a look. So that'd be the probability of Jack. Given that we have a Heart, we'd have to check to see, is that equal to the probability of just getting a Jack? So let's do a quick breakdown. So that'd be the probability of a Jack and a Heart over the probability of a Heart. So let's think through this. A Jack and a Heart. Well, there's one of those. There's one out of the 52. Over Hearts. Well, what's the probability we randomly pick a Heart? Well, there's 13 out of 52 Hearts. Here, the 52s will cancel, and we're left with 1/13. Now, let's think about what's the probability we get a Jack? Well, there are 4 Jacks out of 52, and that simplifies to be 1/13. And sure enough, 1/13 equals 1/13. So these two things are, in fact, independent of each other. So strangely enough, just because they're not mutually exclusive doesn't mean that they're not independent. Here, not mutually exclusive because of the Jack of Hearts. However, the math tells us that these two things are, in fact, independent.